Welcome to The Explainer. Today, we're diving into one of the most fascinating mysteries in the modern universe. It is a literal cosmic detective story, and we're going to unravel it together. Our target? A galaxy actively hiding a staggeringly powerful secret, and it's sitting right in our astronomical backyard. Okay, let's just jump right into this, because this is the ultimate hook. How does one of the brightest, highest energy objects in the entire night sky remain completely invisible to our standard telescopes? It's a total paradox. It's puzzled astronomers for years. And to solve it, we really have to look past what our eyes can see and piece together clues from across the entire electromagnetic spectrum. So our crime scene is located exactly 11 million light-years away. Now, I know that sounds like a lot, but in cosmic terms, that makes it practically a next-door neighbor. We're talking about Caldwell 83, also known as NGC 4945, situated right over in the Centaurus constellation. Because it's so incredibly close to us, we get this unprecedented front-row seat to study how it works. But as you're going to see, proximity doesn't always mean clarity. Now, Caldwell 83 is classified as a Seyfert 2 galaxy. So what does that actually mean? Well, Seyfert galaxies have these intensely active centers. They're powered by supermassive black holes, just totally gorging on surrounding gas and material. But in a Seyfert 2 galaxy, that central engine is heavily obscured. It's hidden from direct view by this massive shroud of material. And for Caldwell 83, this obstruction is taken to an absolute extreme. Section 1. The Illusion, a starburst disguise. So what does this galaxy actually look like on the surface? When you look at Caldwell 83 through a standard optical lens, you see this absolutely beautiful, edge-on-barred spiral galaxy. But the crazy thing is, its most prominent feature isn't a black hole at all. It's a massive nuclear starburst happening right in the central 100 parsecs. That's a span of just over 300 light-years. Stars are being born and dying at incredible, furious rates. Actually, the stellar deaths, these massive supernovas, are driving winds so powerful they've literally swept out a giant conical cavity of dust. So at first glance, it looks like a galaxy completely dominated by fierce star formation. But here is the crucial point, highlighted perfectly in this quote from the researchers. The only evidence for a hidden AGN comes from the hard X-rays. The optical image is marked by dust extinction. See, the galaxy is oriented edge-on to us. That means we're looking straight through the absolute thickest part of its dusty disk. This incredible wall of dust completely blocks the light from the active galactic nucleus, or AGN. Seriously, if we only had optical telescopes, the true monster lurking in the center of Caldwell 83 would remain a secret forever. Section 2. The first clue. Water megamasers. Since visible light is a dead end here, we have to shift our tactics to the radio and microwave spectrum. And wow, this brilliantly illustrates what happens when we do. What you're looking at here is data from the incredible ALMA observatory. It's a map showing submillimeter water maser emissions. If you're wondering what a maser is, just think of it like a naturally occurring laser, but beaming out microwaves instead of visible light. In Caldwell 83, astronomers found water molecules swirling in a tight, edge-on disk right at the very core. This was our first real smoking gun. And astronomers actually used this exact data to weigh the invisible monster. Step 1, they tracked those water masers swirling in the disk. Step 2, by analyzing the Doppler effect, you know, how the light stretches to red as it moves away from us and compresses to blue as it moves toward us, they mapped the velocities of all this gas. And step 3, using simple Keplerian physics, they calculated the exact mass required to keep that gas orbiting so fast. The result? A binding mass of roughly 1 million times our sun, packed into a radius of just 0.3 parsecs. That is less than a single light-year. It's undeniably a supermassive black hole, which immediately begs the question, right? Where is the active nucleus? We have the gravitational signature. We absolutely know a million solar mass black hole is sitting right there, ripping apart material, generating immense friction, crazy amounts of heat. That whole process should be blindingly bright. So why on earth can't we see its light? Section 3. The big reveal, piercing the dust veil. To finally see the light of this hidden monster, we really have to bring in the heavy artillery of astrophysics. Astronomers refer to the dust wall in Caldwell 83 as Compton-thick. Now, this isn't just your everyday run-of-the-mill dust cloud. This is a barrier with a column density so incredibly dense that standard X-rays get completely absorbed and scattered. It acts as an almost impenetrable wall. In fact, only extreme high-energy X-rays, specifically those above 10 kiloelectron volts, have the sheer penetrating power to escape that nucleus and actually reach our telescopes. And here, we finally get the complete picture. On the right, we have a Chandra Space Telescope image looking at soft X-rays. You can see this beautiful soft X-ray plume. That's the starburst activity we talked about earlier, those supernova winds blowing gas right out of the galaxy. But notice, it doesn't show the black hole. Now look at the left. This is from the NUSTAR Space Telescope, which is specifically designed to see hard, extreme X-rays. Bam! Right in the center, piercing completely through that Compton-thick dust, we finally see the blazing core of the hidden active galactic nucleus. But of course, there's one final twist in our detective story. Even in some of these highly powerful X-ray bands, we aren't actually seeing the black hole directly. As the research points out, the spectrum is entirely reproduced by a cold reflection model. The large-scale structure of the emission region is clumpy and asymmetric. So what are we seeing? We're actually seeing the blinding light of the central engine reflecting off a massive 150 parsec clumpy structure of cold gas and dust surrounding it. It's exactly like seeing the intense beam of a flashlight bouncing off a really dense fog bank. Section 4. The Dual Nature, a Multi-Wavelength Universe. So, let's bring all these clues together. Caldwell 83 really forces us to realize that galaxies can lead double lives, you know? On the surface, it wears this starbust disguise, full of supernova winds, swept-out superbubbles, and dense dust lanes that are super visible in optical and infrared light. But hiding perfectly beneath that disguise is the hidden monster. And that was only revealed by mapping H2O megamasers in the radio spectrum and piercing those Compton-thick walls with hard X-rays. This is absolutely crucial, because it brilliantly illustrates why multi-wavelength astronomy is so vital. If we only look with one type of telescope, our understanding of the universe is just fundamentally incomplete. Which leaves us with this final, really provocative thought. If a supermassive black hole, literally powering one of the brightest high-energy objects in the sky, can hide so perfectly just 11 million light-years away from us, how many other cosmic monsters are out there? How many are hiding in plain sight behind a wall of dust, just waiting for us to find the exact right wavelength to see them? Thank you so much for joining me for this explainer, and as always, keep looking up.